Okay, so if you've ever tried running an HDMI cable, say more than maybe 50 feet, you probably know what happens. The signal gets shaky, it flickers, sometimes just gives up completely.
Right. It's a real physical limitation of the standard.
Exactly. Now imagine scaling that up. Think about a big facility, like a sports arena, maybe a huge corporate office or some kind of command center.
Yeah, complex environments.
And you need to get dozens of perfect high-def video feeds. We're talking 1080p out to dozens of screens. And some of those screens are way far away, maybe hundreds of feet.
That's a massive headache, technically and logistically.
That's the exact headache we're digging into today. We're looking at some really specialized gear designed just for this. But there's a twist.
Which is?
It aims for that pro video quality, but it does it using standard IT network wiring, CAT cables.
Ah, okay. Interesting angle.
So our mission today is to do a deep dive into the source material for the WolfPack Lite 80x80 1080p HDMI Matrix Switcher system.
Yeah.
It promises this huge scale, but the really interesting part is how much it leans on typical IT stuff. CAT cables, power over Ethernet, things usually managed by the network guys.
Yeah, that really jumps out because usually for big AV setups like this, you're looking at specialized fiber, maybe coax, definitely custom signal boosters.
Right.
But this WolfPack Lite system, which can be configured all the way up to 80 inputs and 80 outputs, it's kind of blurring those lines, isn't it?
Seems like it.
It's a dedicated video matrix, no doubt, but it's
Right.
designed to operate essentially within the IT infrastructure world,
Yeah.
using network standards to solve a huge video scaling problem.
Let's focus on that scale first, because 80x80, that's enormous.
It really is.
When you look at the specs, it's up to 80 HDMI sources coming in, and then going out, it's up to 80 RJ45 Ethernet ports, one for every screen,
Yeah.
potentially hundreds of feet away.
It's a monster hub, basically.
Yeah.
Centralized switching for a massive number of endpoints.
Yeah. And when you're planning something on that scale, say, for a university or maybe a financial trading floor.
You can't just buy a fixed 80x80 box off the shelf necessarily. What if you only need 50 outputs today?
Exactly. Is it flexible?
Well, that's where the sources highlight a key design choice. It's modular.
Okay. How does that work?
It's built using 4-port cards. So you get a chassis, and then you slot in these cards, input or output, as you need them.
Ah, so you can build your own size, basically.
Precisely. If you need, say, a 48x64 setup now, you buy that configuration, but the chassis might have empty slots.
Allowing for future expansion.
Right. You can just add another 4-port card later if your needs grow. That kind of scalability is pretty critical for big infrastructure investments. You're not locked in.
Makes sense. You plan for the future without overspending today. But, okay, you've got potentially 80 signals flying around. How do you actually manage that? You can't just stand there pushing buttons on the rack.
No, definitely not in a live environment. The sources say it has, the expected robust control options. Dedicated apps, a web browser interface, a WEGY, and yes, still the front panel buttons for direct access if needed.
That web interface is interesting, though. It points back to that IT convergence idea, doesn't it?
It really does. You manage it like a network switch or router, basically. Log in from a computer anywhere on the network. That's standard practice in IT. Now applied here.
Okay, scale and control, got it. But the really tough part, the main engineering challenge the sources talk about, is distance. Sending perfect HDMI quality really far.
Yeah, HDMI just wasn't designed for long hauls. Signal degradation is the enemy.
So what's the limit they're claiming for this system?
The specs say it can push the signal reliably up to 450 feet.
450 feet, that's
It's
huge.
right.
Over standard network cable.
Over standard CT6, yeah, that's, like 1.5 football fields. Sending flawless 1080p video that far over copper is pretty impressive.
Definitely beyond normal HDMI limits, even with basic extenders. So how do they pull that off? What's the tech?
The sources call it LHDT. That stands for Long HDMI Distance Technology. They state it's a proprietary tech, exclusive to them, designed specifically to maintain that signal integrity over those long CTAT cable runs.
And they make a pretty bold claim about the quality.
Right, they do. This is something to note carefully. They claim the picture quality at 450 feet looks exactly like you're using just a 3-foot HDMI cable.
Wow, that's quite a claim. Do they explain how LHDT does that?
The source material doesn't really dive deep into the physics or the specific signal processing involved to, definitively prove it to us here. But the fact that their entire high-end system relies on it, well, it suggests they're confident.
Fair enough. And thinking practically for installers, What about the type of CT cable? Does it absolutely have to be the newer CT6?
Good question. The sources say CT6 is recommended, especially for new installs, for best performance and future-proofing.
Right.
But they explicitly state it works flawlessly with older CT5E cable, too.
Okay, that's actually a big deal.
Huge. Because ripping out existing, perfectly good CAT5E to run CT6 everywhere is expensive and disruptive. So for retrofits in older buildings, that backward compatibility is a major plus. You use what's already there.
Right. And speaking of making installation easier, let's talk power over Ethernet, PoE.
Yeah.
Because with potentially 80 outputs. Wow.
Yeah, PoE is almost essential at that scale. Think about it.
Wow.
Without PoE, you'd have 80 little receiver boxes, one behind each TV or display.
And each one needs power.
Each one needs its own AC power adapter. You need to find 80 power outlets near the screens, manage 80 power cords.
Nightmare. Just asking for problems.
Total nightmare. So the PoE of HDMI receivers are a massive convenience. The main matrix unit sends the low voltage power needed by the receiver right down the same Ethernet cable that carries the video signal.
Okay.
So boom, you eliminate 80 power bricks, 80 messy cables near the screens, and you centralize the power source back at the main rack.
Which, again, feels very IT network standard.
Exactly. Standard practice for network switches powering phones or cameras, now applied to AV receivers.
All right, let's shift to performance. Speed matters, especially if you're switching between, say, live security feeds or financial data. Any lag is bad.
Very bad. Tolerances are low in those environments.
So what do the specs say about switching speed and latency, especially considering those 450-foot runs?
This is where you see it's aimed at the pro market. The sources quote really fast numbers, 80 millisecond switching.
Okay, 80 meters. What about latency, the delay?
Same figure. 80 millisecond latency. So less than a tenth of a second for the switch to happen and for the signal to travel and appear on screen.
That seems very quick, considering the potential distance.
It is. For comparison, human reaction time is significantly slower. So for operators needing near instant switching between different cameras or data sources, 80 meters feels instantaneous.
Yeah, you wouldn't perceive that delay.
Right. And achieving that low latency across potentially 450 feet of copper suggests some pretty sophisticated internal processing to handle signal timing.
It sounds like more than just a fast switch, though. They seem to have packed in other features, value adds.
Definitely. It's not just a basic matrix. One of the biggest things mentioned is free video wall processing.
Free. Usually that's an expensive add-on, right? Separate processors.
Exactly. Building a video wall where multiple screens act like one giant display typically needs dedicated, often costly, external hardware and software. Having that capability built into the matrix itself is a significant cost saving and simplifies the setup.
Huge advantage.
Okay.
What else? What about dealing with different video sources, like old cameras and new computers?
Yeah, mixed signals are common. The sources highlight resolution scaling is available right on the cards.
So it can take, like, a 720p feed and output it correctly to a 1080p screen.
Precisely. Or downscale if needed. It handles that translation automatically, ensuring you don't get blank screens or errors just because your sources aren't all the same resolution. Very important in command centers or older building upgrades.
Okay. Anything else notable?
They also mention the ability to handle separate audio on all the cards, so you can route video to the screen but send the audio feed somewhere else, like a dedicated sound system or a broadcast mix.
Useful for pro setups.
And there's even an optional quad view card. Lets you put 4 sources onto one screen simultaneously. Good for monitoring stations where physical screen space is limited.
So this much tech, this much customization, it implies a pretty specialized company behind it. Who are they?
The source's name, HDTV Supply, Inc., says they've been certified since 2003, operating for about 24 years in the AV space.
Okay.
And importantly, they're listed as an HDBaseT.org approved adopter.
What does that signify?
HDBaseT is a major global standard for long-distance multimedia transmission over network cable. Being an approved adopter means they align with recognized industry standards, even while using their proprietary LHDT for, presumably, enhanced performance or distance. It adds a layer of credibility.
Got it. So, established player, adhering to standards. Now, the big question, cost. This sounds like serious infrastructure. What's the investment level look like?
Yeah, it's definitely positioned as a commercial or enterprise tool, not something for your home theater. The pricing reflects that.
So that build-your-own modular approach starts somewhere.
The base price listed for starting a custom build is around $600, but Obviously, that's just the entry point before you add cards.
Right. And for the large pre-configured systems, they list as examples.
That gives a clearer picture of the full investment. A 40 by 80 system is listed at $19,750. A 24 by 76 configuration is $18,400.
Okay, so we're talking serious budget items.
Yeah.
Tens of thousands of dollars.
Absolutely. This is for organizations that have a clear, large-scale need for this kind of centralized long-distance video distribution and the budget to match.
And given all the options, the modularity, the scaling, quad view cards, it makes sense they push for consultation.
Yeah, the source material mentions contacting them directly for a custom matrix switch based upon your unique needs. They're essentially engineering a tailored solution for each large project. So if we boil it all down, the key takeaway for you, the listener, is this. The WolfPack light system looks like a really specialized solution tackling a major AV challenge. It combines massive switching capacity up to 80 by 80 with impressive long-distance capability 450 feet over standard CA cable using their LHDT tech.
And simplifying things along the way.
Right. Integrated PoE is huge for installation simplicity. Built-in video wall processing saves money and complexity. And the performance specs, like that 80 meters latency, target demanding professional users.
And thinking about that reliance on CAT cables and PoE,
Yeah.
it really underscores a trend, doesn't it?
It absolutely does.
The world of high-end, large-scale AV seems to be converging hard with standard enterprise IT networking, using the same cables, same power methods.
It suggests the days of needing completely separate, specialized AV wiring infrastructure might be fading, replaced by leveraging the ubiquitous, cost-effective network plumbing already in most buildings.
Which leads to a final thought, maybe something provocative for you to chew on. If these complex video matrix systems are now essentially living on the network, using IT protocols like Ethernet and PoE for their core job, how long before the responsibility for designing, implementing, and managing them shifts?
From the traditional AV integration specialist.
Entirely over to the IT network architects and managers. It feels like that convergence demands a new kind of hybrid skill set to run the truly smart buildings of the future.
A fascinating point to consider.
Definitely something to think about. Thanks for joining us for the